Hello, my name is Nidhi Pandey and I'm a technical marketing engineer with Palo Alto Networks. In this video, we will talk about how to build a centralized security architecture with AWS Gateway Load Balancer and Palo Alto Networks VM series firewall to provide security controls for your inbound, outbound, and east-west traffic flow. To start with, this is the architecture which we are going to build. We have two application VPCs wherein we have applications behind an application load balancer, and we have our centralized security VPC with the gateway load balancer and VM series firewall. We are going to use a distributed model for inbound traffic flow, and hence we have an endpoint deployed in the application VPCs respectively, and we are using a separate endpoint for outbound flow and east-west traffic flow as well. So let's get started. To start with, let's go ahead and create the three VPCs that we need. So I have already created the VPC 1, the application VPC 2, and the security VPC, and I've also assigned the respective subnets for each of these VPCs. As a next step, we need to create the subnets for these VPCs. I have already created the subnets in each of these VPCs. So let's look at the subnets for the VPC 1, and you can see that we need two subnets for the load balancer. I have two subnets created for the two applications which will be running behind the load balancer. I also have a subnet for the gateway load balancer endpoint, the transit gateway attachment, and I'm creating a jump host as well, so that if any configuration needs to be done on the applications, I can access using the jump host. I have similar configuration in VPC 2 as well. And you can see I have two load balancer subnet, a jump host, transit gateway subnet, and the endpoint subnet. Now going to the security VPC, I have the subnets defined for the private interface of the firewall, the management interface, the transit gateway attachment. I have two separate subnets for the gateway load balancer endpoint, which will reside in the security VPC itself. And I have also dedicated a subnet for the NAT gateway for my outbound traffic. Next, you would go ahead and create internet gateways and attach it to these three VPCs. So let me name this gateway as VPC 1. And now I'm going to attach it to the VPC. So let's select VPC 1 and attach it. Similarly, we'll go ahead and create the internet gateways for the other two VPCs as well. So now I have all the three internet gateways created and attached to the respective VPCs. Now in the next step, we are going to launch the instances in the application VPCs and run web server. So let's go to the EC2 console, go to instances. We are going to use the launch instance wizard. Let's name it app1. I'm going to use the Linux VM. Let's create a new key pair. I'm going to name it GWLB key. Let's create the key pair, gets downloaded. Select the app VPC 1, the subnet for app1. I'm going to keep it enabled. Now let's create a new security group here, and I'll name it app security group, and I'm going to allow SSH, and I'm going to allow HTTP communication from anywhere. We can leave the rest of the settings default. Go ahead and launch the instance. While this instance is getting launched, I'm going to create another instance in the same VPC, and I'll also create an instance in the application VPC 2. I'll be using the similar setting and use the same security group for all the three applications. In the VPC 1, make sure that the second application is running in the second availability zone, because we would want the load balancer to load balance between the two availability zones. So I paused the video for launching these instances. So now I have everything in the running state. I have two applications in two separate availability zones in VPC 1. I have one application in VPC 2 and two jump hosts in each VPC. Now before I proceed any further, I need to run web server in these application instances. I'll also disable the key-based authentication for the instances so that I can SSH easily later when I want to send the traffic from the jump host. Otherwise, you will have to copy the key to the jump host and then use the key-based authentication. So let's go ahead and add a route table for the instances so that it is accessible from internet. Go to the VPC console, go to the route table, and we are going to create a route table. Let it be in the VPC 1. I'm going to associate this with my applications and also my jump. Now we will be editing this route table later. Once we have load balancer front-ending the applications will not be reachable from the outside. So we will modify the route table later, but for the initial configuration, let's go ahead and associate these 3 subnets with this route table. I'm going to add a default route via the internet gateway. We also need to change the permission of the key before we can SSH into the instances. So let's go to the download folder. So now let's go ahead and access the instances. So application VPC has a public IP here. I need to be a root user to perform any command. Let's go ahead and run the set of commands needed to run the Apache server. And I'm going to copy paste the commands. All right, so the configuration is done. To validate, let's see what files are created, and we can see that the index.html file is created. For the load balancer check, we also need to make sure we have a health check file existing in this particular location. I'm just going to touch. And let's make sure the file exists. We are going to perform the same set of configuration in the second application in VPC 1 and the application running in VPC 2 as well. I'm going to pause the video for a bit while I perform the same steps. After installing the web server, we are going to disable the key-based authentication for this instance now. So to change this setting, you need to log into this file, come to the section where it says password authentication, and it should be set to no. So change it to yes. Once you have made your change, save the config, and then you can restart the SSH service. Once the service is restarted, you can go ahead and set the password, and now you can access the instances without the key. Okay, so at this point I have all the necessary configuration in place for my instances. To make sure that the web server is running, you can try to access the instance over the public IP, and you can see that we can reach this instance. At this point we are all set. So on our instances, we have started the web server. We added the healthcheck.html file for the load balancer health check, and we also edited the SSH file to enable the password authentication. The next step is to create the target group and create the application load balancer in the application VPCs. From the EC2 console, let's go to the target group section. Click on create target group. We will choose the target type as instances. We can leave this default setting. Select the VPC, click next. Forgot to give it a name, and I'm going to name it target group VPC 1. Let's remove the hyphen, click next, and I'm going to select 2 instances and create the target group. Now let's associate a load balancer. For that, go to the load balancer section, create a load balancer. I'm going to choose the application load balancer. I'm going to give it a name, LB for VPC 1. It's going to be an internet facing load balancer. It's going to reside in VPC 1, and it should be mapped to 2 availability zones. So I'm going to use the appropriate subnets which I had already created. Let's choose the second subnet. I'll create a new security group for the load balancer and give it a name. I'm going to allow web access. It's going to be in VPC 1. And I'm just going to add a TCP rule for port 80 because this is what I'm going to use for accessing the load balancer. I'm going to access it over the HTTP port 80. So let's create this. Okay, we missed something. I'm going to use the source as default. Now that we have created the security group, let's go back to the load balancer creation page, refresh the section, and select the security group. I'm going to remove the default. Select the target group which we just created, and we can leave the rest of the settings as default and create the load balancer. So load balancer is going to take a while to come up. Meanwhile, I'm going to create the similar configuration for my VPC2 as well. So I'll go ahead and create another target group of type instance. I'm going to name it VPC2. Select the app VPC2, click next, select the instances, add it, and then create. So now we can create the load balancer for VPC2 as well. So create a load balancer of type application load balancer. I'm going to name it load balancer VPC2. It's going to be an internet facing. Select the app VPC2, select the zones, allocate the subnet in each zone. So I'm going to use the first subnet, and in the second zone I have the second subnet. Okay, now we can go ahead and select the security group. Again, I can create a new security group from here, and I'm going to name it load balancer security group VPC2 for second VPC. Add a rule for port 80, create the security group, and now we can reference this security group in our load balancer creation page. So refresh this and it should show up in the drop down. So I have it here. I'm going to remove the default, select the target group, can leave rest of the settings default, and create the load balancer. So once the load balancer state turns to active, we need to make sure that the target group is healthy. So let's go to the target group section again. We can see that both these instances are reachable from the load balancer. Let's check the second target group, and we have just one instance added, and this shows as healthy. So now we have load balancer front-ending our instances. In the next step, we are going to launch the VM series firewall in the security VPC, and we are going to launch it with ETH0 as the data subnet and ETH1 with the management subnet. Gateway load balancer by default sends traffic to only ETH0 of its target instances, and hence we also need to enable interface swap command so that ETH0 becomes the data and ETH1 becomes the management. We also need to enable the plugin so that VM series can process the traffic passing through the gateway load balancer. We are going to use launch instance to launch the VM series firewall. Let's give it a name. We're going to search for it in the marketplace. We can select the bundle 2. We should be okay with this version, so click on continue. We can leave the instance type to default, the key pair, edit the network settings. We'll deploy it in the security VPC. ETH0 is going to be the data subnet, so I'm going to use the private interface as part of the advanced network configuration. So ETH0, here I'm going to select private security group. The security group here allows the UDP access on port 6081, which enables the gateway load balancer communication with the firewall. In the second interface, I'm going to select the subnet for management, the security group for management, which allows the SSH and HTTPS communication. As part of the advanced configuration, we will enter the interface swap command and enable plugin for GWLB inspect. Now go ahead and launch the instance. This is going to take few minutes. So now that the firewall is up, let's check the configuration. So we have 23.1 and 23.2. So go to the elastic IP section, allocate an elastic IP. We're going to add a firewall management, allocate, and the next step is to associate this with the right interface. So I'm going to associate this with the network interface. This is the interface for the management. The private IP associated is 23.2. Click on associate. Now I already have a route table created for my firewall subnet and configure the management command. So if you look at the route table here, This has a default route going via the internet gateway of the security VPC. Select the VM and we have the elastic IP here. Now we are going to use this IP to access our firewall, and we need to enable the management from the CLI. Open a terminal. So once you have logged into the firewall, on the configure prompt, configure the password for your management access. Re-enter the password. And we should be all set to access the firewall via the web. Let's open a new tab and access the firewall on the elastic IP. It's going to give you a certificate warning. Accept and proceed to the portal. Use the password which you configured via the CLI to log in. Now before we proceed, let's make sure that we commit the changes. We missed the step earlier, so I'm going to commit it. And now we can terminate the SSH session. So going back to the management console, go to the network section, and now we need to create a network profile for interface management. Click on add. I'm going to name it and enable HTTPS for the gateway load balancer health check. Let's go to the interfaces section. Select ETH1/1. Interface type as layer 3. Go to the config section. Create a new virtual router. We're going to name it data. For IPv4 section, select DHCP client. Go to advanced section and select the management profile which we just created. We can leave the rest of the settings to default and click on OK. And now go ahead and commit the changes. Once you have committed the changes successfully, the interface link should come up as green. Next step is to create a allow all policy. Now VM series treats traffic as intrazone when integrated with gateway load balancer, and hence the default intrazone rule to allow all traffic is needed. This is a best practices recommendation to override the default intrazone rule with deny. So I'm just going to name it allow all. Can leave the source as any, destination as any. I'm going to leave application and leave everything as default option. We'll make sure the action is set to allow and click on OK and commit the changes. Now before we go back to EC2, there's one more set of configuration which we need to do, which is basically configuring the subinterfaces. Now this is needed because we would want to associate the gateway load balancer endpoints with the specific zones for visibility purpose. So I'm going to create a subinterface. So highlight the ETH1/1 and click on add subinterface. I'm going to start with 10. Add a value of 10, and we can leave the netflow profile to none. Select the same virtual router and we will create a new zone for VPC1. So we will map this interface to VPC1 traffic. So we'll call it VPC1 inbound. Click on OK. And in the IPv4 tab, select DHCP client and you can leave the rest of the settings to default. Click on OK. We will create another interface we'll make it 11, tag value 11. Select the same virtual router and we will create a new security zone for the VPC2 and map it with the VPC2 inbound flow. Under the IPv4 tab, select DHCP and click on OK. Now we need two more subinterfaces for the security VPC, wherein we will map them to our outbound and east-west flow. Let's give it the tag value of 12. I'm going to change the virtual router and select a new zone, and I'm going to name it security outbound. Click on OK. And the last interface, which will be, so we have 10, 11, 12. I'm going to name it 13, tag value of 13, virtual router, and then assign a new zone for security east-west. Click on OK. Change the IPv4 to DHCP client and then click on OK. Now, once you have made these changes, configured the sub interfaces, go ahead and commit the changes. In the next step, we are going to create target group with VM series firewall and enable the Geneve protocol, because gateway load balancer uses Geneve to communicate with the firewall. And we are going to configure the gateway load balancer and verify that the target group is healthy. Go to the EC2 console and scroll down to the load balancing section, select target group, click on target group. We'll choose the target type as instance. We'll name it firewall TG, firewall target group. The protocol would be Geneve. We are going to use this target group in security VPC. Leave the health check to default. Click on next. Select the firewall VM. Create the target group. Now, once you have done that, you can go to the load balancers. Click on load balancer. Create. Let's give it a name. We are going to map it to security VPC in the right zone, and we are going to map it to the data subnet of the firewall. The target group which we just created, then create the load balancer. Now, load balancer will take few seconds to turn to the active state. So now that the gateway load balancer is active, go to the target group section again, and you would notice that the target group health status has turned to initial, and it's going to move to healthy state once the health check succeeds. This is going to take a while, so we'll pause it for a moment. After a few minutes, you will notice that the health status has turned to healthy. In case it doesn't turn healthy, just make sure you have the right port configured, and also make sure that under the network interfaces section for the data interface of the data interface of the firewall, you have your source and desk check disabled. At this point, we have our 3 VPCs configured, and now we are going to create the transit gateway attachment, enable the appliance mode on the security VPC attachment, and also configure the gateway load balancer endpoints in each VPC. Now, I'm going to create a transit gateway. So from the VPC console, go to the transit gateway section, click on create transit gateway. I'm going to name it TGW and add an ASN number, and I'm going to select auto accept. This is optional section, and click on create transit gateway. Okay, our transit gateway is up. Now let's go ahead and create the attachments. So go to the transit gateway attachment section. Now let's click on create transit gateway attachment. I'm going to name it TGW ENI VPC1 associated with the transit gateway we created. The attachment type is VPC. We are going to add it to the VPC1, and I'm going to just use one zone for the attachment. In case you have multiple zones configured, you will have to create the attachments across different zones. Make sure you have the right subnet, and then click on create transit gateway. Similarly, you will go ahead and create transit gateway attachments for VPC2 and security VPC. So at this point, I have the 3 transit gateway attachments created and associated with the right subnet for the 3 VPCs. This is going to take few seconds for the transit gateway attachments to be up. Now, in case you are using multiple zones and firewalls deployed across multiple zones, you also need to enable the appliance mode for the security VPC attachment. And this is done to make sure that the response traffic is routed to the same availability zone as in the source traffic, and it maintains the symmetry. So to do that, you will have to open a Cloud Shell and enter the specific command from the Cloud Shell. So you will have to replace the security VPC attachment for this value, and the appliance mode will be enabled, and you will get traffic symmetry with multiple availability zones. So let's see what's the transit gateway ID is. So select this, and we are going to replace value and enter the command. When you get an output like this, then it means that the command is successful. Now let's create the endpoint service. So for that, let's go to the VPC console and go to the endpoint service. Click on create endpoint service. We'll give it a name. This is a gateway load balancer. We're going to select the gateway load balancer. We can uncheck this option for acceptance and then click on create. Go to the endpoint section, click on create endpoint. We are going to deploy endpoints in each of the application VPC, and we'll deploy 2 endpoints in the security VPC for outbound and east-west traffic. So first we're going to deploy it in the application VPC. Select other endpoint service. In this section, we will have to enter the service name of the endpoint which we just created. And for that, let's go to the endpoint service and copy the service name, paste the service name, verify the service, select the VPC, and then select the subnet for this endpoint. And I've already created a subnet, so I'm going to use that subnet and create endpoint. Similarly, we are going to create the endpoints in the second VPC. So I have now created all the 4 endpoints. Now endpoints are zone specific. So if your VPC has multiple zones, make sure you have your endpoints deployed in each zone within your VPC. At this point, when we have our endpoints created, we will associate these endpoints to the subinterfaces of the firewall using the following command, and this will be executed from the firewall CLI. Firewall CLI. So you can get the endpoint ID from the endpoints you created. So this is the endpoint ID which you need to replace in the command. I've already configured the commands for the respective endpoints, and I'm just going to copy paste these commands in the firewall CLI. To verify the association, you can use this command, and you would see that these endpoints have been associated with the respective interfaces. At this point, our infrastructure is all set, and the next step is to configure the routes. Till now, we created 3 VPCs with applications, load balancers, endpoints, transit gateway. In the security VPC, we configured the gateway load balancer behind the VM series firewall with sub-interfaces, and we configured the endpoints in the security VPC as well. We are going to configure the routes such that for inbound flow, the traffic from internet gateway towards the load balancer is routed towards the gateway load balancer endpoint within the application VPC, and the traffic for any outbound or inter VPC communication is routed towards gateway load balancer endpoints in the security VPC. So if you look at the route table in the application VPCs, I have 4 route tables here. The IGW route table has an edge association. I have a route which says any destination to the load balancer subnet should go via the gateway load balancer endpoint configured in the VPC. If you look at the load balancer route table, it is associated with the load balancer subnet, and the routes which we have added. This is a route for the return traffic wherein we have added a default route to go via the gateway load balancer endpoint. Now for application VPC, since we want the east-west traffic and the outbound traffic to be inspected in the security VPC, and we have a dedicated set of endpoints in the security VPC, we need to route the traffic towards the security VPC. So for that, we have created a subnet association with the application subnet. I have a default route which points towards the transit gateway attachment. If you look at the gateway load balancer endpoint route table, it is associated with the endpoint subnet, and there is a default route which points towards the internet gateway. Similarly, we will be configuring the route table in our second VPC as well. So you can see that the IGW has an edge association. The load balancer subnet is associated with 2 subnets, and for my application VPC, again, I have a default route pointing towards the transit gateway. Now we need to configure the routes in the transit gateway. So let's go to the transit gateway route table. We'll first create an application route table or the spokes route table. I have associated the 2 VPCs for this route table. Now if you go to the routes, I'm going to create a default route pointing towards the security VPC attachment. So anything coming from the 2 VPCs need to go to the security VPC attachment. I need to create a second route table which will be for my security VPC. This will be associated with the same transit gateway. Create the route table. Once the route table is available, you can associate this with the security attachment and add a static route which will say anything towards the VPC1 should go via the VPC1 attachment, and the next static route which will say anything towards VPC2 subnet will go via VPC2 attachment. So now we have the routes configured in the transit gateway as well. Next, we are going to configure the route in our security VPC. So we have configured the routes up to this point now. Now coming to the security VPC, we need to create a route for the security VPC attachment to send the traffic to the appropriate endpoint. So anything towards VPC1 or VPC2 subnet will go to the east-west endpoint, and anything towards the internet will be forwarded towards the outbound endpoint. Now, once the traffic reaches the endpoints are going to send the traffic towards the gateway load balancer. Gateway load balancer is going to forward it to the VM series for inspection, and it comes back to the same endpoint. At the endpoint, we need to have the right routes configured for the traffic to be forwarded in the next direction. So if you look at the outbound endpoint, I have a default route is configured to send the traffic towards the NAT gateway. At the NAT gateway, I have a default route to send the traffic out via the internet gateway. Similarly, in the east-west endpoint, for anything for VPC1 traffic will be forwarded towards the attachment, and anything for the VPC2 traffic will also be forwarded towards the attachment. So let's go ahead and see how the route table looks like. I have already created the route table, and you can see that I have a route table for east-west endpoint, the outbound endpoint, the NAT gateway, and the transit gateway attachment accordingly. Now we are all set to send the traffic and test our setup. Now let's test the traffic for inbound connection. For an inbound flow, when a user tries to access the load balancer, based on the route table, it is routed towards the endpoint. Endpoint has a private link towards the gateway load balancer, hence it's going to forward it towards the VM series firewall. The firewall inspects it, sends it back to the same endpoint. Since it's in the local route, it will forward it to the load balancer, and load balancer will then forward it towards the instance. In the reverse direction, when the instance initiates the reply based on the route table, it is going to send the traffic towards the endpoint again. The endpoint is going to send it towards the gateway load balancer and towards the VM series for inspection. The traffic comes back to the same endpoint after inspection, and then based on the route table, it is forwarded outside via the internet gateway. Let's test the outbound flow now. So let's look at the DNS name of the load balancer in VPC1. We can copy that, open a new tab. So we can see that it's hitting the instance 1. Now, if we keep trying this load balancer, it will probably load balance between the two instances. And we should see the traffic flow in our firewall as well. Go to the monitor section, and under the traffic logs, if I refresh this, and we do have some logs coming in from the VPC1 zone. So source is somewhere in the internet, and this is the load balancer subnet. Now, if you look at the detail, it's mapped to the specific interface, and this is mapped to the VPC1 traffic. Now let's test the same with the VPC2, and we'll take the DNS name, open a new tab, and let's try to access the load balancer, and we can see that this has reached the instance. Now if we look at the logs, we should see a traffic map to VPC2, and there you go. We have source somewhere in the internet, and the destination is the load balancer, and we can see that it's mapped to the right zone as well. So the zone-based segregation gives you visibility into where the traffic is coming from. For outbound traffic flow, when the application initiates a connection towards the internet, it finds a route towards the transit gateway attachment. So the traffic gets forwarded to the transit gateway attachment, which then forwards to the transit gateway. It's going to look in the spokes route table where it finds a match for the default destination, which is towards the security VPC attachment. At the security VPC attachment, there is a route which points towards the outbound endpoint. So the traffic gets forwarded towards the endpoint. At the endpoint, The traffic gets forwarded to the gateway load balancer. The load balancer forwards it to the VM series. VM series is going to map it to the right zone, apply the policy, send it back towards the outbound endpoint. At the endpoint, it finds a match in the route table for NAT gateway for its default destination. So the traffic gets forwarded to the NAT gateway, and at the NAT gateway, we have a default route pointing towards the internet gateway. In the reverse direction, when the traffic comes back from the internet, it hits the NAT gateway. NAT gateway has the route entry to send the traffic towards the endpoint. So the traffic gets forwarded to the outbound endpoint. Outbound endpoint is then going to forward it towards the gateway load balancer. Load balancer forwards to the VM series. It comes back to the endpoint after inspection. Next, it's going to look in its own route table again and finds a match towards the transit gateway attachment for the VPC1 or VPC2 traffic. Hence, the traffic gets forwarded towards the transit gateway. At the security route table, it finds an entry to send the traffic towards the destination via the VPC1 attachment, and it reaches the VPC1 attachment, and from there it gets forwarded towards the applications. Now let's see this in action. So to test the traffic, I'm going to connect to the jump host first. From here, I'm going to access the instances. Let's get the IP of the instance first. Okay, we'll copy this, enter the password. And from here, let's try and access a website. So I'm going to use wget command to access this website. Let's go to traffic logs, and we should see a log entry in the outbound zone. All right, we can see that there is an entry in the outbound zone. So we have an outbound traffic which is hitting a firewall, and this is the destination, which would be the server IP address. The third test. So when the application in VPC1 wants to communicate with application in VPC2, it finds a route entry in its route table which points it towards the transit gateway attachment. The transit gateway is going to forward it towards the transit gateway, which is where it finds a route entry in the spokes route table towards the security attachment. The traffic is forwarded towards the security attachment, and this is where the route table is referenced again, and it finds an entry to send it towards the east-west endpoint. So we have two endpoints in our security VPC. So we will forward the traffic towards the endpoint, which is catering to the east-west traffic flow. The endpoint is going to forward it towards the gateway load balancer. Gateway load balancer is going to send it to the VM series. VM series will map it to the right zone, apply the policies, send it back towards the endpoint, and this is where the route table is referenced again, and it finds an entry to send the traffic towards the attachment. At the attachment, the traffic gets forwarded towards the transit gateway via the attachment, finds an entry in the security route table wherein the destination is towards the VPC2 attachment. Hence, the traffic gets forwarded towards the VPC. Even in the reverse direction, when the application in the VPC2 sends a response, it gets forwarded to the transit gateway. It's going to refer the route table again, forwards it towards the transit gateway attachment, sends it to the right endpoint. Endpoint forwards it towards the VM series and gateway load balancer, comes back to the same endpoint, sends it back towards the transit gateway. At the transit gateway, it's going to refer the route table again and forwards the traffic towards the VPC1 attachment. So let's see this in action. Now we are going to make use of the same jump host. So we are already connected to the application instance 1 in VPC1, and from here we'll try to initiate a ping traffic towards the VPC2. So let's see what's the IP of the VPC2 instance. Copy this address and let's send a ping traffic. And we can see that the ping is successful. Let's go back to our VM series management, refresh the page for the logs, and we should see the traffic matching with the east-west zone. And you can see that the source is in the VPC1 and the destination is in the VPC2, and it's a ping traffic. This brings us to the end of this demo. To summarize, we saw that Gateway Load Balancer with VM series firewall provides you a centralized security architecture, protects your inbound, outbound, and east-west traffic flow. It is easier to scale since this is a centralized security. It is easier to add a new VPC or remove a new VPC and make minimal changes, which is pointing the route towards the security VPC. With the help of load balancer and multiple availability zones, this architecture provides you resiliency and redundancy as well. This brings us to the end of this video. Hope you liked it. You can find more information about VM series deployment in public and private cloud environment in our live community page. Thank you for watching.